Hey guys, welcome to day 18. So last time we met, I kind of talked about what molar mass is. And to make it simple, the molar mass is basically the atomic weight of an atom expressed in grams per mole. So if we look at copper, we could say that it's 63.55 grams per mole. Now, we can use this as a conversion factor, and basically what this is saying is that 1 mole of copper has a mass of 63.55 grams, and that is going to allow us to convert from moles to grams or grams to moles. So I know when we introduced the atomic weight, we said that it was AMUs, but now what we're going to do is we're going to use that atomic mass as a conversion factor so that we don't actually have to count atoms. So for our first example, we want to calculate the mass of 3 moles of copper. And if I look at the P table, the molar mass is 63.5 grams. So what I want to do is I want to cancel out moles. And the way that I'm going to do that is by putting it on the bottom. And I want to end up in grams, and the way that I do that is by putting it on the top. Now I want you guys to show unit cancellation, and the way that you're going to do this is usually just with kind of a single line, and I like to color code these so you guys can see. And we're going to put the 1 with the mole and the 63 with the grams, and when we do that, we are going to multiply by the factors on the top. So 3.00 times 63.55, and I'll give you an idea what my calculator says. My calculator says 190.65. And we are, let's talk about sig figs real quick. We have 3 sig figs there. I've actually used 4 sig figs there, and don't let the 1 on the bottom limit your sig figs. So we have 3 sig figs times 4 sig figs. We can keep 3 sig figs. So the 0 is followed by a 6, which means we round it up to a 1. And 191 grams of copper is equivalent to 3 moles. So let's do another example. This time, we're going to go from grams to moles to atoms. So this is going to be a 2-step conversion. Step 1 is we're going to go from grams to moles. And the way that we're going to do that is by using the mm, the molar mass. But then we want to go from moles to particles. And in order to do that, we are going to use Avogadro's number. So we are given 1 gram of oxygen. We want to know how many oxygen atoms that is. So step 1, we are going to go from grams of oxygen to moles of oxygen. Don't forget to show unit cancellation along the way. Okay, so pink cancels out pinks. But now we don't want moles, we actually want atoms. So we're going to put moles on bottom and atoms on top, and I've abbreviated that, and you guys can see that moles cancels out moles. Now you guys may have noticed that I have not plugged any numbers in. I usually like to start with units and then go back and plug in my numbers later. So my molar mass for oxygen is 15.9994, and remember the 1 goes with the mole. I'm going to round it to 2 decimal places, so I'm going to call it 16.00. So 15.9994 actually rounds up to 16. And then I'm going to say that 1 mole is equal to Avogadro's number. So E means times 10. So 6.02 times 10 to the 23. So in my calculator, I'm going to multiply by the factors on top. So 1.00 times 1 equals, well, 1. Then I'm going to divide by 16.00. And the last step is multiply by 6.02, second button EE23, and my calculator gives me 3.7625 times 10 to the 22. Now, think about sig figs. We've got 3 sig figs, 4 sig figs, 3 sig figs. I can keep 3. So my final answer is going to be 3.76 times 10 to the 22 atoms. Final answer. All right, so take a look at the worksheet down below. I'm not going to do every one. I'm going to do every other one. So for the first example, number 4, we are going to go from grams of sodium to moles of sodium. So you might want to put moles down here. That's what you're actually calculating. So grams go on bottom and the moles go on the top. And if I look at sodium on the P table, it is 22.9897. So I'm just going to say that 1 mole of sodium is 22 32.99 grams. Don't forget to show unit cancellation. Grams cancel out grams, okay? So 3.75 times 1 is 3.75, divided by 22.99 is going to be a decimal value of 0.16311. Now, sig figs, 3 on top, we've got 4 on the bottom. I can keep 3 sig figs. So I'm going to call this 0.163 moles of, I can even put the element in there, sodium, 0.163 moles of sodium. All right, so B is really identical to A, it's just a different element and a different number. So now, let's do the same thing down from here for B. But this time, we are going to go from moles to grams. So I've been given moles of sulfur, and I want to convert that into grams of sulfur. So I want to cancel out moles. The moles go on the bottom. I want to end up in grams. Grams go on top. Not a bad idea to show unit cancellation at this point. And then I'm going to go back and fill in my numbers. So I've got my P table out, and it is 32.06 grams per mole. So the 1 goes with the mole, and the 32.06 goes with the gram. Now, in this case, we're going to be multiplying by the factor. So 0.025 times 32.06, and then we're going to divide by 1, but we realize that that's not going to change our answer, and my calculator gives me 0.8015. And if I look at my sig figs, I've only got 2 sig figs here, and I've got 4 sig figs, so I can keep 2 sig figs. I am going to call this 0.80 grams, okay? Letter B is really just the same as letter A. It's just a different element and a different number, okay? All right, now 6 and 7, we're going to do some two-step calculations. In number 6, we are going to go from, I believe, from grams to moles to atoms, and I realize it's been kind of erased right there. So I want to go from grams to moles, and then I'm going to put another line, and I want to go from moles to atoms in this case. And atoms is what I want my final answer to be. I realize I kind of crossed off what I'm supposed to do, but I know you guys can see it on your copy. So if I look up helium, it's a monoatomic element. 1 mole of helium is 4.00 grams. And grams cancel out grams. And now I want to go from moles to atoms. So 1 mole is Avogadro's number, 6.02 times 10 to the 23 atoms. And now I'm going to get my calculator out and multiply. So 27.01 times 1. Oops, I should probably put a line right here just to separate my conversion factor. So 27.01 times 1 divided by 4.00 gives me a number of about 6.7, and then I'm going to multiply by 6.02 times 10 to the 23, and my calculator gives me 4.065 times 10, I'm running out of space, times 10 to the exponent 24. So it was actually 4.06, but because the 6 was followed by a 5, I rounded it up because we can keep 3 sig figs. So 4.07 times 10 to the 24. All right, one more example. In this case, we are going to go from atoms to moles, and then moles to grams. So atoms are going to go to moles, and then we're going to go from moles to grams, okay? So 1 mole is Avogadro's number times 10 to the 23. And 1 mole of plutonium, I need to find plutonium, is 244 grams, okay? So they're not even giving us decimal values for that. So, all right, we're going to take the 8.90, second button EE24. We're going to multiply by 1 mole, and then we're going to divide by 6.02, second button EE23, that's Avogadro's number. And then we're going to multiply by 244. And when I do that, my calculator gives me 3,607 grams, 3 sig figs, 3 sig figs, 3 sig figs. I need to round to 3 sig figs, so I'm going to call it 3,610 grams. All right, guys, I left some examples on the table for you to do. If you have questions, email me directly. Leave a comment on Google Classroom. I miss you guys. I love you guys. I'll talk to you soon.